So page 3 is not one big question. Every question stands by itself. The first question, I'll tell you this for sure. The first question is just KE equals 1/2 mv squared. PE, this is not even on the mock test, I'm telling you. P is mgh, right? So it's really, really simple. No conservation of energy, just how do you calculate the kinetic, how do you calculate potential, okay? B is just like the first question on here, is a power is work over time question. C is going to be, C is actually a 1-to-1 conservation of energy. D is 2-to-1 conservation of energy. But it might also be a 1-to-2, I'm not sure, I don't remember. Okay. Two types of things. So it's like force times distance turning into this, right? And then E is a 2-to-2. So sometimes it really helps to know how many different things there are. Yeah, doesn't it? Does it help to know that it's like a 2-to-2? Yeah, it kind of helps, right? So I'm telling you that's what it is. C is a 1-to-1, D is a 2-to-1 or a 1-to-2, right? And then E is going to be 2-to-2. So you can know what to look for. This is on the real test. I'm telling you that's what they are on the real test. This is a very good page. Typically, people do really well on this page. Page 3. This is an exclusive, just for people that are, either on internet or watching right now. Yeah. Yeah, the real test is this. That's what it is. And I picked this one, conservation of energy. I picked those to put on the mock test. Yeah, let's do it.
No, with the second part of
1-to-1 means like you have one
thing
on one side, then one thing on the other side, and then 2-to-1.
Yes, exactly. Two of these things to one of those. COE is conservation of energy. Okay, so A, power is work divided by time, right? Or let's do the magic. Do the magic triangle, and you have to make like a little sound when you use this, right? Okay. We want to know time, and the question is, it's a 34-watt heater, and it's 1,250 joules of heat or work in that case, right? It's just energy, really, right? So that's going to be work divided by power. So A part 1 is going to be 1,250 joules divided by 34 watts. Yeah? And that's 36.76 seconds. Right? And then it says, how much heat would it put out in 1.8 minutes? Well, that's sort of tricky because 1.8 minutes doesn't mean 1 minute 80 seconds or something weird like that, right? So 1.8 seconds would be, time is 1.8 times 60. Right? So we got to convert that to seconds. So 1.8 times 60. Indeed is 108 seconds. And then what is work? Work is
power times time.
put. It's put. Right? So work is power times time. So 34 joules per second, or 34 watts, right? Times 108 seconds. Why did my 8 get so funny looking? I don't know. 3672 joules. And the test is exactly like that. It's exactly. We just changed the numbers. That's part A, right? Say it again. I don't think so. We haven't found any wrong yet. We might yet, but I don't think so.
Okay. Yeah,
Yeah, huh? That wasn't wrong. Yeah, huh? Yeah. Oh, by 2. We rounded.
Yeah.
You nilly. I don't think yeah, huh is a thing you can say either. Yeah, huh it is. I'll never win this argument. Yeah, huh?
Take it easy.
That was good. Who hushed? That was a very fierce hushing. Okay, so here's a picture I've got for part B, right? B is supposed to be a 2 to 1, and indeed it is, right? Okay, so what do we have here? What kind of energy do we have here? At the top of the hill while we're moving? What kind of energy do we have here?
Kinetic.
And? Yeah, there we go, right? So this is going to be 1260 times 1/2 times 6.7 squared, right? Plus 1260. Right? And then at the bottom of the hill, yeah, it's not moving. Doesn't have any kinetic potential energy, right? So it's just force times distance. Yeah. Yeah, here it's 1 FmV squared plus mgh. Say it again. Oh, because something in my brain made me write kinetic first. Is that okay? No, it doesn't matter because it's commutative. 3 plus 4 is the same as 4 plus 3. My math teacher told me that, right? So all there is on this side is force times distance, right? So it's 34,000 times distance. So this is 1/2 mv squared plus 1 mgh. So that's the 2 that turns to the 1. So if I do this side here, I'm going to do it all in one swell foop. This whole side is and now I'm going to divide by 34. Yeah. So are we okay on B? Is B okay?
Yeah.
No? Yes? And then C. C is difficult, right?
Yeah.
A cart is at the bottom of a hill. I think it's going to go to the top of the hill since the hill is mentioned, right? And there's a force of 272 newtons that acts for 5.8 meters. Right? And this is a 62 kilogram cart. Right? And it's already going 6.17 meters per second. Holy cow. Right? So it's already moving 6.17 meters per second. 272 newtons speeds it up, so it's going to be going faster, but then it goes up the hill. Right? And the hill is, we don't know how high it is. Ha ha ha. Right? But we know that the cart at the top of the hill is, the car at the top of the hill is going 3.78 meters per second, right?